Okay, today I'm going to explain the mechanism for IL-17 induction of TFHs in germinal centers, and even in the absence of IL-21. And the reason this comes up is to try to fit together two pieces of data. One is that in the absence of IL-21, in a BXC2 mouse, IL-17 can promote development of TFHs in germinal centers. But previously it was thought that IL-21 was necessary to promote follicular TFH development. So let me just point out here, here's a regular T follicular helper cell. It produces IL-21, and it has certain upregulation of certain molecules, including SLAM, that promote its interaction with B cells. So this is just thought that the simple story is this cell acts on B cells through direct interactions, maybe through SLAM, and by production of IL-21. That arrow is not even on here. The IL-21 acting on the B cell. So that's the old story. And it's also known that IL-21 is important for several things. One paper showed that IL-21 was, this direct effect on B cells is not as important, although I'm not sure what the latest is on that. But IL-21 does this, but it also does something even more important, is it drives development of TFHs. So IL-21, the main role of IL-21 in germinal center development is to drive development of T follicular helper cells. But also, we also knew from past that IL-21, or other people have shown, IL-21 also drives Th17s that produce IL-17. So this part is known down here. Now, we showed in BXC2 mice, Th17s have their own unique role in promoting germinal center development by IL-17 production, upregulating RGS13, 16 B cells, RGS16 and TFHs, and bringing the T and B cell together, maybe through SLAM interactions. SLAM is involved, maybe IL-21 direct, so this part is known. Now the new part that sort of brings together some of the old stuff is there is a new cell, TFH, that does not need to produce IL-21. It only produces IL-17. And we showed this in the last data. We gated on ICOS positive, CXCR5 positive, so they have the phenotype of TFHs. But they don't. But there's two populations of these cells. Some produce IL-21, some produce IL-17. This is in the BXC2 mouse. So this shows you that IL-17 is sort of an intrinsic property. We've shown this before. These mice, T cells from these mice can really produce a lot of IL-17. And that has something to do with the germinal centers, as we talked about. But what comes up here is using the same mouse, if you inject, but what's new is this Th17 is strongly dependent on IL-21. And we didn't really know that very much. But in IL-21 knockout BD2, IL-17 production is very low, so this doesn't work. It's known this happens, but it's very low. But if you add IL-21 in the 21 knockout, IL-17 goes way up. That's that curve that we always are struggling with. This is IL-17 production, and this is so it goes like day 8. It shoots way up to a very high level. This is after you give this is LAC-Z, this is IL-21. So we say this is we use this as an entry point to say, look, a key role in BXC2 mice, we already shown is IL-17, and also a key role for IL-21 is to induce IL-17. So somehow you get the reviewer to think that therefore the TFH's role is of course to produce IL-21, of course it drives itself, of course it makes IL-17. But in BXC2 mice, IL-17 is especially high. And IL-17 is especially high, and IL-21 is especially capable of producing IL-17. So therefore, you twist it around and start with your thing. So why is IL-17 so important? It's so important even with IL-21. So then then this is a switch. You got to say, all right, let's remove IL-21. Let's take out IL-21, and we'll show you why IL-17 is important. So we got the IL-21 knockout, and we put in add IL-17, and in those mice, even in the absence of IL-17, they make these, I propose they make these cells, these TFHs, that have SLAM, and actually that comes out later. But we propose they still can make germinal centers. I think, you know, the first step is that do they make T follicular helper cells? And the answer is yes. In those mice, even without IL-21, you get a TFH produced. So, but it's probably not this TFH. They're ICOS6 or 5 positive. But these TFHs produce a traditional IL-21. So they must make these TFHs. And these TFHs can respond to IL-17. You know, actually it's an exogenous IL-17 produced by the ad. They respond to IL-17 by, and this gets to the rest of the paper, by upregulating SLAM. I don't know if we showed RGS16, but they upregulate ICOS and CXCR5. So they were always there in the VXC2 mice. It's just we didn't quite know, you know, we didn't ascribe much importance to them because we had a lot of IL-17, Th17s, and we had a lot of IL-21. But if you strip this cell away, then you can start to dissect the role of this cell. I call it the IL-21 less TFH. You know the TFH IL-21 less. Less. They got the helpless and so forth. So this is a TFH, the absence of IL-21. And then, so that's there, and we got the data to show that. That's if you divide it IL-17 without IL-21. Next, can it function? Okay, yeah, your phenotype, it's ICOS6 or 5. It can't produce IL-21, but it might do something, might do something to help these, especially with this thing going on, IL-17. So then we show, yes, it does, because that's where the germinal center, the germinal centers develop when you give 21 knockout IL-17. And then do they make antibodies? Yes, they do make and they make autoantibodies because, without those cells, you give this IL-17 and, they add IL-17, they make antibodies. And then what's the properties of these cells? And that's where, towards the end, you get into, well, they have high SLAM, I would put that first, in vitro, IL-17 in IL-21 knockout mice, if you add IL-17 in vitro, it upregulated SLAM. And and then I think there's a part about they make real plasma, so they really make real plasmablasts, mature plasmablasts, because that'd be a property. So at the end, finally, you look at, but do they really drive these cells to become plasma cells, typical, the IgD, IgM plot? And yes, they do. They can give these cells full function. So in conclusion, even though it doesn't mean IL-20, so I said this in discussion, it doesn't mean IL-21 is not important, because it is very important. It induces very high levels of IL-17. But it also shows that it induces these cells to make even more IL-21, more IL-17. But it also shows that independent of these cells, it shows why maybe IL-21 is trying so badly to induce these IL-17. Because, even in the absence of these cells, all you got to do is have high IL-17, and you get a TFH-like cell that can take the place of this IL-21 producing TFH. So that's this model.